Today we're going to continue with solving these equations. It's part 2 and it follows all of the same rules that we looked at in the last video. So the most important thing is to remember what you do to one side you do to the other. And in order to move numbers to one side of the equals and to isolate for our variables, you always want to do the opposite operation. Yesterday, all of our examples only had variables on one side of the equals. So today what we're going to look at is what happens if we have variables on both sides of the equals. For example, here we have an a on the left side and an a on the right side. We are still trying to make this statement true, and in order to make the statement true, that means that we wonder whatever we substitute in for a here and substitute in for a here, it'll make our left side equal to our right side. So we're going to move all of our variables left and our non-variables, our constants, to the right. So 8a subtract 2a, because it was positive here, we always do the opposite operation. And then we have 17 plus 7, because it was negative 7 here. So when we move it over, it's the opposite operation. I'm now left with 6a is equal to 24. 6 multiplied by a, the opposite operation of multiplication is division. What I do to one side, I do to the other. My 6's cancel out, therefore leaving me with a isolated by itself. 24 divided by 6 is equal to 4. So now we want to check to see if the statement is true, to see whether we actually did this correctly or not. So we check here down below that our left side, our 8a minus 7, will be equal to our right side, 2a plus 17. So in my calculation so far, I'm saying what makes this statement true, the left side equaling the right side, is that a has to be equal to 4, as I've stated here. Let's see if I'm right. So anywhere there is an a, I'm going to substitute in 4. 8 times 4 is 32, subtract 7, which gives me 25. So if done correctly on my right side, when I substitute in 4 in for a, this should equal 25 as well. 2 times 4 plus 17. 2 times 4 equals 8, plus 17 is 25. So therefore, this statement is true when a is equal to 4. Let's look at another example where there's actually fractions involved. So for example, x divided by 4 plus 4 is equal to 2x divided by 3 subtract 1. The easiest thing that we can do here is to first remove all of our denominators by multiplying all 4 terms by a common denominator so that we can cancel out our denominators. So I'm going to multiply all my terms by 12. It's important to be sure you do it to all terms involved. So we can see here that 12 divided by 4 is equal to 3. There's nothing to cancel out in our second term, so we can leave that as is. That will become 12 multiplied by 4. 12 divided by 3 is equal to 4. And then there's nothing to cancel out in our last term. So let's clean this up now so we can see what we have. So we have 3 multiplied by x plus 48, 12 times 4, is equal to 8x, 4 times 2, subtract 12. Now this is much like our example up above, where we need to move all of our variables to one side and all of our non-variables to the other. It doesn't matter whether you move them all left or all right. So this time in this question, to work with positive numbers, I'm going to move my variables to the right and my constant to the left. So my 48 comes first, and then I will add 12 to it because it was negative 12 here. Then I have 8x subtract 3x. leaving me with 60 equal to 5x. I divide both sides by 5, leaving me with an answer of x being equal to 12. So if I've done the work correctly, after I check it, my left side will equal my right side. Do that now on the sheet that's given and see whether x is equal to 12. On your sheet as well that you were given, one last example that I want you to try for class the next day is to see what you believe x would be equal to for our last example. Our last example being x divided by 3 plus 4 is equal to 2x divided by 9.